In the previous slide, we were given a value of Q and asked to compute the total cost of production at that value of Q. In this example, we're given the opposite. We're given a total cost of production, namely $948, and we're asked to find the number of items that can be produced if we spend that amount of money. So we're still dealing with the same cost function. Visually, what we're doing is we're saying, let's locate the value $948 on the cost axis, which is the vertical axis. When we do that, we see that as we move from the vertical axis over to the line, we locate the point on the line, and then we can go down to the horizontal axis, and the question becomes, what is the value of Q that does the job? And you can see it's somewhere between 40 and 50. If we had to guess, it might be 43, 44, maybe 45. So in order to know for sure, we have to do the calculations. So in this case, we're going to set up the equation as appropriate. The $948 is a cost. It's not a Q, so we're not going to substitute it in for Q. Instead, we're solving for Q. And so here, we're solving a linear equation. And when you have a linear equation, your goal is to isolate all of the terms that have the variable Q on one side, either the left or the right, and all of the other terms that are constant on the other side, the opposite side. So in this case, the first thing we're going to do is subtract 750 from both sides to try to get that 4.5 Q term all by itself. That leaves 0 on the right-hand side, and on the left, 198. So 198 is equal to 4.5 Q, and now we can divide both sides by 4.5 in order to get the value of Q. Notice that on the right, 4.5 divided by 4.5 is 1, so we have 1 Q, and on the left we do the arithmetic to get 44. So of course that jives with what we're seeing on the graph. If you look at the horizontal axis, the Q value is very close to 44, and in fact is exactly 44. So the interpretation here would be that you can produce 44 units if your total cost is $948.